On the morning of March 26, 1945, Private First Class Donald Hogan crouched behind a shattered coral ridge on Okinawa, watching orange flame pour from his squad's flamethrower into a Japanese bunker 30 yards ahead. The concrete structure had withstood 3 days of naval bombardment. Artillery shells had cratered the earth around it. Tank rounds had chipped its walls, but the machine gun inside kept firing. Now flame was streaming through the bunker's viewport, a pressurized jet of burning gel that stuck to everything it touched. Hogan watched the black smoke billow from the opening. He heard screaming from inside. Then, silence. What Hogan didn't know, what almost no one understood in March of 1945, was that the weapon destroying that bunker wasn't working the way anyone thought it was. American military planners believed napalm burned hot enough to damage concrete itself. Japanese defenders believed their reinforced fortifications would protect them from fire. Both beliefs were wrong, but the weapon worked anyway, for reasons that had nothing to do with temperature. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The substance called napalm was barely 3 years old when Hogan watched it clear that bunker on Okinawa. In July of 1942, a team of chemists at Harvard University, led by Professor Louis Fieser, had tested their new invention on what is now Ohio Field, across the Charles River from the main campus. They dug a circular pool 60 yards in diameter, filled it with water, then detonated a 70-pound bomb filled with their experimental mixture. The fireball that resulted burned at approximately 2,100 degrees Fahrenheit. It billowed across the water, generating intense heat and thick black smoke. City of Cambridge firefighters stood ready with equipment. Tennis players on adjacent courts paused their volleys to watch. The test succeeded. The mixture, which Fieser named napalm, from the chemical compounds naphthenic acid and palmitic acid that thickened the gasoline, performed exactly as designed. But the temperature measurements from that test would later cause confusion about what the weapon actually did. 2,100 degrees Fahrenheit is extraordinarily hot, hot enough to melt lead, which liquefies at 621 degrees, hot enough to soften steel, which begins losing structural strength above 1,000 degrees. Hot enough, military planners concluded, to damage concrete, fortifications. That conclusion was wrong. Concrete doesn't have a precise melting point because it's a composite material made of cement, sand, gravel, and water. But the components that make up concrete begin to melt at temperatures between 2,700 and 3,000 degrees Fahrenheit. The cement matrix starts melting around 2,800 degrees. Silica sand, one of the primary aggregates, doesn't melt until approximately 3,100 degrees. Napalm burned hot, but not that hot. It couldn't melt concrete. It couldn't even soften it, significantly. The belief that napalm could physically destroy fortifications through heat alone was based on a misunderstanding of both the weapon's temperature and concrete's thermal properties. Yet across the Pacific Theater in 1944 and 1945, American forces used napalm to systematically destroy Japanese fortifications that conventional weapons couldn't touch. The weapon worked devastatingly well. Just not for the reasons anyone thought. The Japanese defensive strategy in the final year of the Pacific War depended entirely on fortifications. After catastrophic losses in the Marianas Campaign during the summer of 1944, Japanese military planners abandoned any hope of defeating American invasions at the beaches. Instead, they adopted a strategy called defense in depth. The goal was no longer to win, but to make every yard of ground as costly as possible for the attackers. Lieutenant General Tadamichi Kuribayashi implemented this strategy on Iwo Jima starting in June of 1944. He had 8 months to prepare the island's defenses before American forces landed. He used that time to create what may have been the most sophisticated defensive network constructed during World War II. The island's volcanic rock allowed for extensive tunneling. Japanese engineers and labor battalions dug 11 miles of tunnels connecting hundreds of defensive positions. These weren't crude cave systems. They were engineered structures with multiple levels, ventilation shafts, ammunition storage rooms, and medical stations. Some tunnels ran 75 feet below ground level. The main command post was buried 30 feet deep with a concrete roof 10 feet thick. Above ground, the Japanese built reinforced concrete pillboxes at key terrain features across the island. These weren't hastily constructed field fortifications. They were permanent structures designed to withstand sustained bombardment. The walls were typically 2 to 5 feet of reinforced concrete. Some positions had even thicker protection. The structures were positioned to provide interlocking fields of fire, meaning attackers advancing toward one position would be exposed to fire from multiple other positions. The defensive network incorporated the natural terrain. Mount Suribachi, the volcanic cone at the island's southern tip, was honeycombed with tunnels and gun positions. The plateau in the island's center was covered with pillboxes, bunkers, and hidden artillery positions. Every cave entrance, every rocky outcropping, every depression in the terrain was either fortified or covered by defensive fire from another position. American intelligence officers studying reconnaissance photographs before the invasion recognized some of the fortifications. They counted approximately 644 pillboxes and bunkers visible from the air. What they didn't realize was that this represented perhaps 1/3 of the actual defenses. Most positions were hidden underground or so heavily camouflaged that aerial photography couldn't detect them. The fortifications on Okinawa, where the next major invasion would occur 2 months after Iwo Jima, followed similar principles, but on a far larger scale. The island had been Japanese territory since 1879. Japanese forces had more time to prepare and more resources to work with. They built defensive lines across the southern third of the island, anchored on limestone ridges and hills that provided natural strongpoints. The Shuri line, centered on the historic Shuri Castle, consisted of concentric defensive zones stretching across the island's width. Forward positions slowed attackers and channeled them into killing zones. Main defensive positions, protected by reinforced concrete and natural limestone caves, stopped attacks entirely. Reverse slope positions, hidden on the backsides of ridges, engaged attackers who managed to reach the crest. The entire system was designed to absorb attacks and inflict maximum casualties. These fortifications represented a calculated bet by Japanese military planners. They believed that concrete and earth could protect defenders from American firepower superiority. They believed that forcing Americans to assault prepared positions would result in casualties so severe that American political will would crack. They believed the weapons that had devastated Japanese forces in earlier campaigns, naval artillery and aerial bombing, would be ineffective against fortified positions. They were partially correct. Naval gunfire from battleships and cruisers could destroy above-ground structures and suppress defenders temporarily. But shells couldn't penetrate deep, underground positions. They couldn't reach defenders inside reinforced bunkers. Artillery bombardment preceding the Iwo Jima invasion lasted 3 days. Battleships, cruisers, and destroyers fired thousands of shells at the island. When Marines landed on February 19, 1945, they discovered that most Japanese positions were intact. Aerial bombing faced similar limitations. Heavy bombers couldn't achieve the precision needed to hit small, fortified positions. Even direct hits on bunkers often failed to penetrate. The concrete and earth overhead absorbed the blast. Defenders inside might be stunned temporarily, but the position would remain functional. The weapons that could destroy fortifications, demolition charges placed directly against bunker walls or inside structures, required infantry to approach within touching distance of Japanese positions. That meant crossing open ground under fire, reaching the fortification despite machine gun fire, grenades, and mortar fire, then placing explosives and withdrawing before detonation. Casualties among demolition teams were catastrophic. By early 1945, American forces needed a weapon that could kill defenders inside fortifications without requiring infantry to close to point-blank range. That weapon existed. Portable flamethrowers had been used in limited numbers since early in the Pacific War, but the early models were unreliable. The Mohn flamethrower, introduced in 1942, suffered from ignition failures, limited range, and short burning time. The M22 flamethrower, standardized in February of 1944, solved most of these problems. It used a chemical cartridge ignition system that worked reliably, even in humid tropical conditions. It held 4 gallons of thickened fuel that could be projected 40 yards. Most importantly, it used napalm as its fuel mixture. Pure gasoline burns hot but fast. A flamethrower using gasoline would project a stream of burning liquid that dissipated quickly and had limited range. Napalm, thickened with aluminum soaps, burned slower and stuck to targets. The gel-like consistency meant the flame could be projected further and would adhere to whatever it hit, continuing to burn. The weapon's specifications were straightforward. The M22 weighed 68 pounds fully loaded. It consisted of 3 tanks mounted on a backpack frame. 2 outer tanks held the fuel mixture. The center tank held compressed nitrogen at 300 to 350 pounds per square inch, which pressurized the system. When the operator pulled the triggers, nitrogen pressure forced fuel through a nozzle where a chemical igniter set it ablaze. The weapon could fire for 8 to 9 seconds continuously. That doesn't sound like much, but 8 seconds of continuous flame projection was enough to completely saturate a bunker interior, consume the available oxygen, fill the space with toxic combustion gases, and raise the temperature inside to levels incompatible with human survival. The problem wasn't the weapon's effectiveness. The problem was keeping the operators alive long enough to use it. A Marine carrying a flamethrower was immediately identifiable. The tanks on his back were visible from hundreds of yards away. The bright orange flame and distinctive black smoke when he fired marked his exact position. Japanese defenders quickly learned to prioritize flamethrower operators as high-value targets. Doctrine called for 4 riflemen to provide covering fire for each flamethrower operator. These covering riflemen were supposed to suppress enemy positions while the operator approached, provide security during the actual attack, and cover the withdrawal. But doctrine assumed the covering riflemen would survive. On Iwo Jima and Okinawa, that assumption proved catastrophically optimistic. Flamethrower teams sustained casualty rates exceeding 90% in some units. Operators who survived one mission rarely survived a second. The mathematics were brutal. Each bunker or pillbox required 1 flamethrower operator to approach within 40 yards, stand, exposed for 8 to 9 seconds while firing, then withdraw across open ground. Japanese defenders concentrated fire on that operator from multiple positions. Most operators were killed before completing a single attack, yet the weapon had to be used. No other weapon in the American arsenal could reliably clear fortified positions without massive infantry casualties. Naval gunfire couldn't reach inside bunkers, artillery couldn't penetrate, tank guns couldn't destroy reinforced concrete, demolition charges required someone to place them by hand. The only weapon that could kill defenders, inside fortifications from a tactically survivable distance, was the flamethrower. And that weapon was about to reveal something profound about the nature of warfare, about human psychology, and about the difference between what military planners thought was happening and what was actually occurring on the volcanic rocks of Iwo Jima and in the limestone caves of Okinawa. The story of how napalm actually worked and why Japanese defenders feared it more than any other American weapon begins with a fundamental misunderstanding about fire, heat, and concrete. The mechanics of what happened when napalm entered a concrete bunker were poorly understood in 1945. American military planners believed the weapon worked primarily through heat. The 2,000-plus degree flame would physically damage the fortification, they thought. Maybe soften the concrete. Maybe crack it through. Thermal shock. The intense heat would kill defenders through burns. Japanese defenders, for their part, believed their fortifications would protect them. Concrete walls 2 feet thick, steel-reinforced doors, ventilation systems designed to circulate air during prolonged bombardments. These fortifications had withstood 3 days of naval gunfire at Iwo Jima. They had survived aerial bombing. Surely they could withstand a weapon that only burned for 8 seconds. Both sides were wrong about the mechanism. Both sides were right about the result. When a flamethrower operator fired into a bunker viewport, several things happened simultaneously. The napalm gel, propelled by 300 pounds per square inch of nitrogen pressure, shot through the opening in a concentrated stream. The igniter cartridge at the nozzle set the fuel ablaze as it left the weapon. The burning gel entered the bunker as a coherent jet of flame, not a diffuse spray. Once inside, the napalm behaved differently than liquid gasoline would have. The thickening agents gave it viscosity. It stuck to surfaces. It flowed across floors. It splattered against walls and clung there, continuing to burn. A single 8-second burst could deliver approximately half a gallon of burning gel into an enclosed space. The temperature inside the bunker spiked immediately. Not from the concrete heating up. The concrete barely warmed, but the air temperature jumped to between 1,500 and 2,000 degrees Fahrenheit within seconds. That temperature differential between scorching air and relatively cool concrete walls created the first fatal effect. Human skin can tolerate exposure to air at 98.6 degrees Fahrenheit indefinitely. That's body temperature. At 120 degrees, extended exposure causes heat exhaustion. At 140 degrees, the body's cooling mechanisms begin to fail. At 200 degrees, serious burns occur within minutes. At temperatures above 500 degrees, exposed skin burns instantly. Inside a bunker filled with burning napalm, the air temperature exceeded 1,500 degrees. Defenders couldn't survive even moments of exposure. Their clothing ignited, their skin blistered and charred. They couldn't see through the flames and smoke. They couldn't breathe the superheated air without searing their lungs. But the heat itself wasn't the primary killer. The second effect was oxygen deprivation. Napalm burns through oxidation, the same process that makes any fire burn. Fuel molecules combine with oxygen molecules from the air. The chemical reaction releases energy as heat and light. The PARM byproducts are carbon dioxide and water vapor. The process consumes atmospheric oxygen at a prodigious rate. A concrete bunker or cave is an enclosed space with limited ventilation. Japanese defensive positions typically had 1 or 2 firing ports, each maybe 6 inches tall by 12 inches wide. Perhaps a rear entrance, usually with a steel door. Some positions had ventilation shafts, but these were small, designed to provide air circulation during prolonged bombardments, not to replace oxygen consumed by fire. When napalm burned inside such a space, it consumed oxygen faster than ventilation could replace it. Within seconds, the oxygen concentration in the bunker dropped from the normal atmospheric level of 21% to single digits. Below 15% oxygen, humans begin to experience symptoms similar to altitude sickness. Below 10%, loss of consciousness occurs within minutes. Below 6%, death from hypoxia follows rapidly. The Japanese defenders faced an impossible choice. Stay inside where the oxygen was disappearing and the temperature was lethal, or exit through the rear entrance into American rifle fire. Some chose to stay. They died from hypoxia, burns, or both. Some chose to run. They died from bullets. A few, very few, managed to evacuate before the flames reached them or before oxygen levels dropped critically. Most of these were killed by covering riflemen. The third effect was carbon monoxide poisoning. Incomplete combustion of hydrocarbon fuels produces carbon monoxide, a colorless, odorless gas that binds to hemoglobin in blood more readily than oxygen does. Even relatively small concentrations of carbon monoxide in the air can be rapidly fatal in enclosed spaces. When napalm burned in a bunker, with depleted oxygen levels, the combustion became increasingly incomplete. More carbon monoxide formed. Defenders breathing the air inside the bunker were inhaling a toxic mixture of carbon dioxide, carbon monoxide, and remaining oxygen at concentrations that caused loss of consciousness within minutes. The combination of all three effects, extreme heat, oxygen depletion, and carbon monoxide poisoning, created a killing mechanism that worked regardless of whether the flames actually touched the defenders. Many Japanese soldiers found dead inside bunkers after flamethrower attacks showed minimal external burns. American observers initially concluded the weapon caused instant death through shock to the nervous system from the intense heat. This conclusion led to the characterization of flamethrowers as mercy killers in some chemical warfare service publications. The reasoning was that death came so quickly, without prolonged suffering, that the weapon was actually more humane than being shot or blown apart by explosives. This characterization was fundamentally misguided. It misunderstood both the physiological effects of the weapon and, more importantly, the psychological experience of the defenders. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The psychological effect of flamethrowers on Japanese defenders was perhaps more significant than the physical effects. Fear of fire is primal. Humans evolved alongside fire for hundreds of thousands of years. The fear response to fire lives in the oldest parts of the human brain, the limbic system, which processes emotions before conscious thought can intervene. Every soldier can be trained to accept the possibility of being shot. Bullets are abstract until you experience them. Most soldiers haven't been shot before combat. They can imagine it, but the imagination lacks the visceral reality that comes from actual experience. Training can prepare soldiers to function under fire because the fear, while real, can be managed through discipline and conditioning. Fire is different. Everyone has been burned. Everyone knows what even a small burn feels like. The pain is immediate, intense, memorable. The human mind can extrapolate from the pain of touching a hot surface to the horror of being engulfed in flame. That extrapolation happens automatically, without conscious effort, and it generates terror that training cannot fully suppress. Japanese soldiers on Iwo Jima and Okinawa had withstood sustained bombardment. They remained in their positions through naval gunfire that shook the earth and collapsed some tunnel systems. They endured aerial bombing. They fought through conventional infantry assaults with rifles, grenades, and demolition charges. Their discipline and training allowed them to function through all of this. Then the flamethrowers appeared. The reaction was immediate and obvious to American observers. Positions that had held through hours of conventional attack would evacuate minutes after a flamethrower team approached. Marines reported seeing Japanese defenders abandon fortified positions and run into rifle fire rather than face burning napalm. Raymond Hart, a corporal with 2nd Battalion, 24th Marines, 4th Marine Division, was shot in the head on February 20th, 1945, the second day of the Iwo Jima campaign. A bullet fired by a Japanese sniper entered and exited his helmet above the front brim, creasing his skull but not penetrating his brain. He was knocked unconscious briefly but refused evacuation. He remained with his unit for the entire 36-day battle. Hart watched Japanese defensive tactics evolve as the battle progressed. Early in the campaign, defenders would remain in pillboxes and bunkers through sustained artillery barrages and infantry assaults. They would fight from their positions until killed or until American demolition teams placed charges directly against bunker walls. The defensive doctrine emphasized holding positions to the last man. When flamethrower teams began, systematically attacking fortified positions, the tactics changed. Hart watched a flamethrower operator fire an 8-second burst through a bunker viewport. Within seconds, 3 Japanese soldiers came running out the rear exit. They weren't shooting. They weren't throwing grenades. They were just running, trying to escape the fire. Hart's squad shot them as they emerged. The bunker went silent. Hart later said he'd watched Japanese soldiers hold positions through hours of artillery fire and coordinated infantry assaults, but 8 seconds of flame made them abandon a fortified position, run into certain death. That told him something profound about human psychology. Training and discipline could overcome many fears. The fear of burning alive wasn't one of them. This pattern repeated across Iwo Jima and Okinawa. Marine Corps intelligence officers documented it in after-action reports. Japanese units that fought tenaciously against conventional weapons would break when flamethrowers were deployed. Defenders who remained in pillboxes through sustained artillery bombardment would evacuate when flamethrowers appeared. The response wasn't universal. Experienced units with veteran leadership sometimes maintained discipline and accepted casualties, rather than abandoning positions. Some defenders chose to die in place, rather than face either fire or rifle fire outside. But even veteran units showed signs of stress when flamethrowers were used repeatedly. The psychological pressure of knowing that any moment might bring burning napalm into your fortified position eroded morale in ways that conventional weapons didn't. Lieutenant General Tadamichi Kuribayashi, commanding the Japanese garrison on Iwo Jima, recognized the threat. He ordered his troops to prioritize flamethrower operators as high-value targets, kill them before they can deploy their weapons, concentrate fire on anyone carrying the distinctive tanks, make the weapon too costly for the Americans to use. The orders were followed. Japanese snipers and machine gunners targeted flamethrower operators on site. The casualties were staggering. In one Marine battalion on Iwo Jima, the portable flame unit sustained a casualty rate of 92%. That meant nearly every operator was killed or wounded. The few who survived one mission rarely survived a second. But killing flamethrower operators before they could attack required accurate fire at moving targets carrying distinctive equipment. Japanese defenders tried. They succeeded often enough that Marine flamethrower casualties were catastrophic, but they couldn't stop all the operators. And each operator, who survived long enough to reach a pillbox, could clear it in seconds. The Americans recognized both the weapon's psychological impact and the vulnerability of portable operators. The solution was to mount flamethrowers on tanks. The development of flame tanks had been slow initially. The Marine Corps had left flamethrower tank development primarily to the Army, placing orders for just 9 tanks per division for early Pacific campaigns. But combat experience in the Marshall Islands and Marianas demonstrated the desperate need for armored flamethrower support. At Schofield Barracks in Dar, Hawaii, a classified unit called the Flamethrower Group began converting M4A3 Sherman medium tanks into flame weapons. The work was done by Navy construction battalions under the direction of Colonel Unmacht. The construction battalions combined elements from 3 different flame unit designs: the Canadian Ronson system, the Navy Mark I, and the improved Navy Mark I that the Navy had tested but rejected. The result was the CBH-1 flamethrower system, quickly superseded by the even better CBH-2. Installing a flamethrower system in a Sherman tank required complex work. Each conversion needed 150 pounds of welding rod and 1,100 electrical connections. The cost ran between $20,000 and $25,000 per tank, equivalent to approximately $300,000 in modern currency. The flamethrower replaced the Sherman's 75mm main gun. It operated on 300 pounds per square inch of pressure, the same as the portable M22. But where the portable unit held 4 gallons of fuel, the flame tank carried 300 gallons. Where the portable unit could fire for 9 seconds, the flame tank could fire continuously for much longer engagements. Where the portable unit had a maximum range of 40 yards, the flame tank could project burning napalm 150 yards or more. The weapon could traverse 270 degrees while firing, allowing the tank to engage multiple targets without repositioning. The Sherman M4A3R3 flame tank was protected by 3 inches of frontal armor. Japanese machine gun fire couldn't penetrate it. Japanese anti-tank guns had to score direct hits on vulnerable spots to disable the tank. The tank carried its own defensive armament, typically a hull-mounted machine gun. The crew was safe inside. The weapon was devastating outside. 8 flame tanks were shipped to Iwo Jima for Operation Detachment. They landed on D-Day, February 19, 1945, but didn't go into action immediately. The Marines waited until February 21st, D+2, before committing the flame tanks to combat. The commanders wanted to assess the tactical situation first. When the flame tanks finally moved forward to support infantry assaults, the effect was immediate. Japanese positions that had withstood repeated infantry assaults, artillery barrages, and conventional tank fire would be cleared within minutes when a flame tank appeared. The Marines quickly learned that a single flame tank could accomplish what an entire infantry company might spend hours trying to achieve with conventional weapons. The flame tanks approached Japanese positions with relative impunity. Machine gun fire bounced off the armor. The defenders couldn't stop the tanks from reaching effective range. Then, the tanks would fire. 300 gallons of burning napalm would splash across fortified positions, flowing into bunkers and cave entrances, consuming everything it touched. Japanese defenders who had remained in positions through conventional tank attacks would evacuate when flame tanks appeared. The Marines learned that bringing up a flame tank would often clear an entire defensive complex without infantry assault. The defenders would retreat through their tunnel systems rather than face the fire. Reports from Marine units across the island documented the effectiveness. Battalion and regimental commanders began requesting flame tank support by name. The tanks became the most requested support weapon on Iwo Jima, surpassing even artillery in terms of how often infantry units called for them. Units would sometimes halt their advance and wait for flame tank support, rather than attempt to clear fortified positions with conventional weapons and accept the resulting casualties. The flame tanks were so valuable that they were pooled among divisions rather than permanently assigned to specific units. Only 4 flame tanks were allocated to each tank battalion, with 3 Marine divisions on the island. That meant just 12 flame tanks total for the entire operation. To maximize effectiveness, the tanks were dispatched from central refueling points to wherever they were most urgently needed. A flame tank might support the 4th Marine Division in the morning, then be moved to support the 5th Marine Division in the afternoon. The dependency on flame tanks revealed something important about the nature of the battle. Iwo Jima wasn't a war of maneuver. It was a war of fortifications. The Japanese had spent 8 months preparing defenses in depth. They'd dug 11 miles of tunnels connecting hundreds of fortified positions. They'd reinforced bunkers with steel plate and covered them with 3 feet of volcanic rock and soil. They'd positioned weapons to provide interlocking fields of fire across every avenue of approach. They'd created a defensive system specifically designed to survive American firepower superiority. Artillery couldn't destroy the positions. Aerial bombing couldn't penetrate the reinforced structures. Naval gunfire, even from battleships, couldn't reach defenders deep in tunnels and caves. The Americans needed a weapon that could kill defenders inside fortifications without exposing American infantry to sustained fire at close range. The flame tank was that weapon. Not because it melted concrete, not because the fire physically destroyed the fortifications, but because it filled enclosed spaces with heat, consumed oxygen, produced toxic gases, and generated terror that overwhelmed discipline and training. The concrete bunkers remained structurally intact after flamethrower attacks. Engineers examining cleared positions found the walls undamaged. The concrete hadn't melted. It hadn't even cracked from thermal stress in most cases. The fortifications had protected the defenders from the physical effects of the fire exactly as designed. But the fortifications had also trapped the defenders in enclosed spaces where fire could consume the oxygen and fill the air with toxic gases. The defensive design that made the bunkers resistant to artillery and bombing made them vulnerable to flame. Enclosed spaces that provided safety from bullets became death traps when filled with burning napalm. Japanese military intelligence officers interviewed after the war confirmed what American observers had documented during combat. Flamethrowers were the weapon Japanese soldiers feared most. More than aerial bombing, more than naval artillery, more than tanks. The reason was simple and terrible. Flamethrowers meant certain death in an enclosed space. A soldier in a bunker could survive artillery. Concrete provided protection. A soldier could survive tank fire. Steel plate could deflect shells. But a soldier couldn't survive fire in an enclosed space. Fire consumed oxygen. Fire filled the space with heat and toxic gas. Fire gave defenders seconds to choose between burning to death inside or running into machine gun fire outside. Both choices led to death, but one was instant, while the other meant burning alive. The American military studied this psychological effect extensively. The Chemical Warfare Service published analyses of why the weapon was so effective. Some officers characterized flamethrowers as more humane than conventional weapons, because they caused death quickly. This characterization was based on observations of bodies recovered after flame attacks, many of which showed minimal external burns. The conclusion was that death had occurred rapidly from oxygen deprivation or carbon monoxide poisoning rather than from burns. Therefore, the reasoning went, flamethrowers were actually more humane than being shot or blown apart by explosives. This analysis fundamentally misunderstood what made flamethrowers psychologically effective. The terror wasn't about how death occurred. It was about knowing you were about to die by fire and having seconds to process that knowledge. A bullet kills before you understand what's happening. An explosion destroys consciousness instantly. Fire gives you time to know you're dying. That knowledge, those few seconds of absolute terror, was what broke Japanese defensive morale. The Battle of Iwo Jima lasted 36 days, from February 19 through March 26, 1945. American forces suffered over 26,000 casualties. Approximately 7,000 Americans were killed in action or died of wounds. Japanese casualties were catastrophic. Of the estimated 21,000 Japanese defenders on the island, only 216 were taken prisoner. More than 20,000 were killed. The Japanese casualty rate exceeded 98%. On Iwo Jima alone, over 360,000 gallons of napalm mixture were used during the 36-day campaign. Approximately 10,000 gallons were consumed daily by both portable flamethrowers and flame tanks. Over 30% of all Japanese soldiers killed on the island died not from bullets or explosives, but from the effects of fire. The weapon the Marines, called their most valuable tool on Iwo Jima, worked not by melting concrete, but by exploiting the fundamental design of Japanese fortifications. The enclosed spaces that protected defenders from conventional weapons trapped them when fire consumed the oxygen. The psychological terror of facing flame broke morale that had withstood sustained bombardment. The weapon succeeded not through the mechanism American planners believed, not through physical destruction of fortifications, but through a combination of physiological and psychological effects that no amount of concrete could defend against. The title question, whether Japanese defenders knew napalm burned hot enough to melt concrete, misses the essential truth. Napalm didn't need to melt concrete. It never melted concrete. Concrete requires temperatures between 2,700 and 3,000 degrees Fahrenheit to melt. Napalm burned at approximately 1,800 to 2,000 degrees Fahrenheit. Hot, but not that hot. What the Japanese didn't understand, what American planners also didn't fully understand until combat revealed it, was that the weapon's effectiveness had nothing to do with damaging fortifications. The concrete walls remained intact. The steel doors survived. The structural integrity of bunkers and pillboxes was preserved. But the defenders inside died anyway, killed by heat they couldn't escape, oxygen they couldn't breathe, and terror they couldn't overcome. The fortifications that should have protected Japanese soldiers instead became their tombs, not because the concrete failed, but because fire in an enclosed space creates conditions incompatible with human survival, regardless of how strong the walls are. The irony was complete. The massive defensive construction effort, the 8 months of preparation, the 11 miles of tunnels, the reinforced concrete bunkers, all of it designed to protect defenders from American firepower, made them more vulnerable to the one weapon that worked by filling enclosed spaces rather than destroying them. Wars are not won by superior tactics alone. They are won by understanding what your weapons actually do versus what you think they do. The Americans discovered this understanding through bitter experience, through watching flamethrower operators die at 92% casualty rates, through trial and error on volcanic rock and limestone ridges. The Japanese learned it too late, after their defensive strategy had committed them to fighting from fortifications that became death traps when faced with weapons that worked differently than expected. The mathematics of warfare are unforgiving. Sometimes the difference between victory and defeat isn't about how hot your weapon burns, but about understanding what actually kills your enemy. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.